perform the following conversions, and these are all temperature conversions. Several of them are between degrees Celsius and Fahrenheit. Let's review what we learned in lecture about the conversion between Celsius and Fahrenheit in either direction. We can plot degrees Fahrenheit versus degrees Celsius on an XY coordinate system. And when we plot the data, we get a straight line. Our freezing point and boiling point for our degrees Fahrenheit, as we know, are 32 degrees and 212 degrees respectively. The point here is that the number of divisions is 180. On the Celsius scale, we have 0 degrees as the freezing point, 100 degrees as the boiling point, and here we have 100 divisions. So the point here is our equation for a straight line. Y is equal to mx plus b. Now we can substitute for the y-axis. We have degrees Fahrenheit. Our slope is 180 divided by 100 to rise over the run, and that's going to be 1.8 times our x-axis, which is degrees Celsius. And then we are going to add the y-intercept, which is 32. So here is our equation then that allows us to convert between degrees Fahrenheit and degrees Celsius. So in our first problem, problem A, we're asked to convert 50 degrees Celsius to degrees Fahrenheit. So let's rewrite that equation because we're going to need it here. So for 9A, our problem is asking us to convert 50.0 degrees Celsius equals question mark degrees Fahrenheit. Well, our equation, degrees Fahrenheit, is equal to 1.8 times degrees Celsius plus 32. Our unknown is, in fact, degrees Fahrenheit, which is already by itself on the left side of the equal sign, so it's just a matter of substituting numbers in. So we're going to have 1.8 times 50.0 for our degrees Celsius plus 32. Now when we do the multiplication here, we're going to get 90.0 plus 32. Now the important thing to understand here is that the 1.8 and the 32 both are exact numbers. And the only number that has a measurement is our 50 degrees Celsius, 3 significant figures. Our 1.8 and 32 have as many significant figures as we need. Therefore, our answer is going to require us 1 decimal point to the right because this has as many decimal places as we need. So adding these two together, we get a value of 122.0 degrees Fahrenheit. Let's go to part B, the problem here. Let's scroll back and see what they're asking us. In part B, they're asking us to convert minus 15 degrees Fahrenheit to degrees Celsius. So let's rewrite that here. So for part B, minus 15 degrees Fahrenheit equals question mark degrees Celsius. Again, as a conversion between Fahrenheit and Celsius, we're going to use the same equation that we used in the previous problem, but we're going to have to do some algebra. Let's start with the equation as we learned it. Degrees Fahrenheit equals the quantity 1.8 times degrees Celsius plus 32. Now this time our unknown is degrees Celsius, so we've got to do a little bit of algebra here. So let's go through it in detail. I'm first going to subtract 32 from both sides of the equation. So I get degrees Fahrenheit minus 32 is equal to 1.8 times degrees Celsius. Let me put that in parentheses or not. Doesn't matter. Next, since we are looking for solving for degrees Celsius, we're going to divide both sides of the equation then by 1.8. 1.8 cancels, and now I'm going to be left with, and let me rewrite it here, degrees Celsius is equal to degrees Fahrenheit minus 32 divided by 1.8. So now we're simply going to substitute our numbers in here. And for degrees Fahrenheit, we have a value of minus, and let's just check the significant figures. That's just 2 significant figures, okay? So it's minus 15 minus 32 over 1.8. So now subtracting minus 15 and minus 32 upstairs, we get minus 47 divided by 1.8, and now doing the division on that, we get a value of minus 26 degrees Celsius. So there's our equivalent temperature for minus 15 Fahrenheit in degrees Celsius. Let's now go and do part C of this problem. Draw a line and scroll back up to the top and see what part C is asking. Part C of this problem is asking us to convert 8.50 times 10 to the second kelvins to degrees Celsius. Basically 850 kelvins, 3 significant figures, reason for scientific notation, to degrees Celsius. Please note Fahrenheit is not involved in here, so we don't have to deal with the equation we're just using in parts A and B. So I'm just going to write it in ordinary notation, knowing that we have 3 significant figures. So we have 850 kelvins, and we're going to convert that to question mark degrees Celsius. So here we need to remember our conversion between Celsius and Kelvin. Degrees Celsius plus 273.15 equals kelvins. Now in this case, our problem is asking us to calculate degrees Celsius given kelvins, so we got to do a little bit of algebra here, which isn't too hard. So degrees Celsius is going to be equal to kelvins minus 273.15, just subtracting 273.15 from both sides of the equation. So our degrees Celsius then is going to be 850. Remember, we have 3 significant figures. I'll represent that with a decimal point there, minus 273.15. So this number does have 5 significant figures. So when we do the subtraction, we will not have a decimal point. And when we subtract, we end up with 577 kelvins. So here's our equivalent temperature. I'm sorry, that's degrees Celsius, not kelvins. So 577 degrees Celsius is equivalent to our 850 kelvins. Let's now go and do the last part of this problem, 9D. And in part D, they're asking us to convert 157 degrees Fahrenheit to Kelvin. Here is going to be a 2-step problem because we first are going to need to convert our degrees Fahrenheit to degrees Celsius, then convert degrees Celsius to Kelvin. So our equation here that's boxed in red is going to be our first step. We're going to have to do some algebra to solve for degrees C. So let's scroll down and get to work on this. Our equation, starting point, degrees Fahrenheit, is equal to the quantity 1.8 times degrees Celsius plus 32. Doing the algebra, because again we are solving for degrees Celsius here, we're going to end up with degrees Celsius is equal to degrees Fahrenheit minus 32 divided by 1.8. I went quickly here. We did this derivation a couple of problems ago. Now we're going to just substitute our values in. 157 degrees Fahrenheit, 3 significant figures, minus 32, infinite number of significant figures, divided by 1.8. We have no decimal places here at the 157, so our answer is going to have no decimal places when we subtract. We divide that. Let's do the subtraction first. 32 from 157 is going to be 125 over 1.8. And then doing that division, we're going to end up with 69 degrees Celsius for our conversion to that temperature scale. Now we need to convert this to kelvins. And we saw that equation in the last problem. Our kelvins simply going to be equal to degrees Celsius plus 273.15. Here we have 69 degrees Celsius plus 273.15. Again, our answer is going to have no decimal places because I've got 2 significant figures here with no decimal places. So when I add these 2 values up together, I'm going to end up with 342 kelvins as my final temperature.